Hi everyone, so welcome back. All right, so this week we're going to start with learning about mod. Okay, so before I get into what that even means, first I'd like us to have a conversation about how do you read a clock. Okay, so I'm talking about like one of these clocks. Okay, so now we don't have to worry about like if we're in military or whatever, or if it's PM, AM. We're just talking about reading a clock like this. Okay. Okay. So I'm going to start by saying time, at least for this clock, can be thought of as mod 12. And if you do want to think about military time, that's fine as well. It's just a little bit less visual, I guess. And so that would be mod 24 if you wanted to try that out. So I'm going to write it in quotes because you don't really know what this means yet. So it could be thought of as being mod 12. So let's talk about what that means. So 1 hour after 12 o'clock, we call that 1 instead of 13, at least on a clock like this. But we know that 13 hours after 12 is 1. And you could do this for a lot of things. 2 hours after 3 is the same as 5 hours after 12. You know, like there's a lot of things like this. So we're kind of used, but that if we were just talking in like normal speak, that would sound ridiculous and weird, right? Like if I was like, oh yeah, well 2 plus 3 is 5, but also 12 plus 5 is 5. It's like, what? You know what I mean? So it really is special how we think about time and stuff. If we mod out by n, okay, and so that's typically how we'll refer to it as well. Modding out by 0 doesn't really make sense. That's kind of what we're already doing in normal math. And then if you mod out by a negative number, that's the same as modding out by the absolute value of that number. Okay, so we'll just work with natural numbers. So let's say, what does that mean? Well, in fancy speak, we say that means we let n be the additive identity or a additive identity. So what does that mean in like normal people language? That means we're letting n also equal 0 in this special land. Okay, so for our special land of this clock, 12 is our additive identity. Okay, and so let's think about it. So if it's so here in my diagram, I guess it's 2 o'clock. Okay, if we say, all right, well, what time will it be 12 hours from now? It's going to be 2 o'clock. Okay, so we added 12 hours to the clock and it was still the same. So it worked as if it was 0. Remember, we're not keeping track of PM, AM, what day it is, anything like that. We're just kind of messing around with the clock or something. I don't know. Okay. All right. So let's do some notes before we jump into things. I just want to stress again, n will always be a natural number. Okay. Here's something else important. We will not talk about multiplication and similarly division in mod. Well, let's say in mod n. Okay, so this is typically how we'll write it. So if we're like modding out by n, where you can write it like this. Like this is our language with it. It's mod n. Okay. And so I'll show you some examples. There's a couple of ways you can write it. So why don't we do this is because it's significantly harder. So in the future of your mathematical career, you might learn how to do multiplication in mod n, but in this class we're just going to focus on addition in mod n. Actually, if you all would like as like an extra or something, or like a fun thing I could do in one of our final weeks, I could give a lesson on how to do multiplication in mod. I just think it's so cool. If I write something with 3 lines, so it looks like an equal sign that's underlined or a bar over an equal sign, it's just an equal sign with 3 lines. This means equivalent. So this doesn't mean that they're necessarily equal in the sense that we're used to things being equal, but We will be learning about equivalence relations, I think, next week. But thankfully, right now it's not extremely important. So I'll show you some examples. So 13 mod 12 is equivalent to 1. So you can write mod 12 like that, or you could write in parentheses. When I was first learning this stuff, I liked doing that. Or what I would do is I would put the other stuff in parentheses. Because when I was first learning this was in number theory, so we would have crazy stuff like this. So I'd put that in parentheses and then the mod 12 at the end. Whatever's fine with you, just as long as we can tell that as long as we can tell what is what. And then the other thing that you can do is you could always also write it on the other side. That's fine as well. That's not a problem. Okay, so parentheses, no parentheses, either way is fine. If you tech up the stuff, what happens is it puts a big space between your number and the mod stuff. Okay. All right, so what this reads is 13 mod 12 is equivalent to 1 mod 12. This one also reads like that. I just didn't write the mod stuff. All right, so equivalent stuff. If you don't get that nuance right now, that's okay. That's not the end of the world. We will talk about equivalence classes and relations later. A reasonable question for any of you to ask me would be, so when do we know that two things are equivalent mod n? Say A is equivalent to B mod n. So first thing I want to talk about that I didn't write a note, so maybe I should have, but we're talking about it now, is A and B. They're not going to make much sense if they're not integers. Okay? But they are allowed to be integers, so they're allowed to be 0, they're allowed to be negative. Okay? I will always assume this. What I mean by that is I will always assume this in mod world, or whatever you want to call it. So never am I going to have like 1/2 is equivalent to B mod n. And part of that is because we just have no idea how to talk about stuff like that. Because remember, we're only going to be talking about addition and subtraction. We're not going to be talking about multiplication. Okay, so let's think about not in mod world. So A equals B, that's familiar. Okay. All right, well, what about, we know that A equals B if and only if A equals B plus 0. So that sounds silly, right? But oftentimes you'll add by 0, which sounds silly in the moment, but really what you're doing is you're doing it in a tricky way. So like maybe you're doing +4 minus 4 or something, you know. This is actually very similar in mod n. Here's the situation. A is equivalent to B mod n if and only if. Okay, now here's where the tricky part comes in. Well, the tricky add by 0 thing. There exists some k in the integers such that A plus kn equals B. Okay? All right. So now maybe it's kind of important, maybe you're starting to see why it's kind of important us talking about equals and equivalent differently. So if we moved over into mod world, if we modded this thing by 12. Sorry, I'm still thinking about the clock. Mod by n. We would get A plus kn mod n is equivalent to B mod n. Well, luckily for us, here I'll put in parentheses, n is the additive identity. So that means that n is somehow equivalent to 0 in our mod n land. Okay, so by adding, so let's talk about kn is equal to n plus plus n k times. And if k is a negative integer, then it would just be, we would be minusing them the absolute value of k times. Okay? All right, so this one's 0 in mod n, these are all 0 in mod n, that's 0 in mod n, that's 0 in mod n, so this whole thing is 0 in mod n. Whether n is negative or not, it doesn't matter. So here, what we end up getting is that this whole thing is 0 in mod n, okay? So now we have a, or a plus 0 mod n is equivalent to b mod n. So a is equivalent to b mod n. And so remember, when I write this equivalent sign, that means that I only need to write it on one side, but it does stand for both sides. So the left-hand side's still in mod n, even though I'm not explicitly writing mod n on the left-hand side. Okay, I know that might seem a little bit crazy, but that's how this whole thing works. Okay, so I showed it in one direction. You could show it in the other direction and give me a complete proof. That would be kind of cool. You have all the tools you need for that. But let's jump into an example, an explicit example. All right, back to our clock. 13 mod 12 is equivalent to, well, 13 is bigger than 12, so I could pull out a 12 out of there. Oh, okay, well, this is 12 times an integer, because we could just think about it as multiplied by 1, right? So by my if and only if above, or we could just be thinking about, well, okay, any multiple of 12 is equivalent to 0, because it's the additive, it's one of the additive identities, okay? So we just get equivalent to 1 plus 0 mod 12, and you don't have to keep writing this 0 thing. So this is equivalent to 1 mod 12. Okay, so if you wanted to be what I used to call in my youth efficiently lazy, and you didn't want to have to write mod a gajillion times, you could get rid of it on the last one. That's the one that I think would make the most sense to me. Negative 11 mod 12. I can always add 0. Well, luckily for me in mod 12, 0 is equal to any multiple of 12. So, well, 11 is just one less than 12, so maybe I'll just add one copy of 12. And where does that get me? Okay, well now, when I'm inside of here, I'm just going to do math like normal. Okay, so that's kind of what's fun about mod, is you're doing math like normal, but now you have this like additional feature. Okay, so what do we get? We get 1 mod 12. So how crazy is that? But somehow you already knew stuff like this, like very intuitively, that if you went back in time 11 hours, so let's say it's noon, okay? If you went back in time 11 hours, you know that you would end up at 1 o'clock. But also you could go forward in time 1 hour and you would be at 1 o'clock. Sure, maybe they're on different days or AM, PM, something, but both times you end up at 1 o'clock. Okay? So how cool is that? But wait a second, we know that 1 mod 12 is equivalent to 13 mod 12, so I can even go on to say this is equivalent to 13 mod 12. So remember, we can always say, there's a lot of things that we can say that are true, but are not very helpful. So this is a scenario where that probably wasn't very helpful. Probably what we wanted was, we wanted to look for this. But it is just cool that we can like circle it back to something that we showed before. Something that I haven't really talked about much yet. I'm talking about adding by 0 a bunch of times here so far. But a question you might have is, well, if I already have that, let's say A is equivalent to B mod N or something, can I like add 4 onto both sides, or maybe like C, whatever integer I want? Well, yes. So then for C some integer, we get that A like plus C or minus C, whatever you're feeling like. So we can still do a lot of our normal math stuff with addition and subtraction and things, just as long as you do it on both sides. So let this already be true. A is equivalent to B mod n. Then we can subtract B on both sides. So we get 0 mod n. Okay, well, if A minus B is equal to 0, is equivalent to 0 mod n, then that means that A minus B has to be a multiple of n. Okay, so then there exists some k in the integers such that A minus B equals k times n. So equals in like outside world, right? Or else how else would they end up being 0? So it could be that k is 0, right? So like if, let's say n is 3 and A and B are both 1. Then 1 minus 1 is just 0. Well, that technically is a multiple of 3, right? It's just 3 times 0. Okay, so we have this, but what does that mean? That means that n divides A minus B. So that's something crazy. So here's a lemma. So A is equivalent to B mod n if and only if n divides A minus B. And that's important. We'll be using that in my third video. I'm going to do lots of examples of mod stuff. Okay, have a good one. Bye.